Hello YouTubers, my name is Jim. My two loves in life are electronics and mechanics. As far back as I can remember, I have always wanted to fix things that stopped working and make things that work better. I recently purchased the 3990 mill from Little Machine Shop. Since it already worked very well, I set out to make it work better and share that process with others on YouTube. So here goes part one, an X-axis table drive shaft. It only took one time setting up my milling vise to realize that this was going to be a necessary modification. I did not want to crank that handle several hundred times around just to square the vise to the table. With this drive shaft upgrade, all you need to quickly move this table is a drill or electric screwdriver and a 10mm socket. These two drawings show dimensions for the two parts that I had to machine. I'll provide a link below to download these drawings. The 25mm recess in the original X-axis table end plate will have to be bored out to a diameter of 29mm with a depth of 3mm to allow room for the bearing. This would not be necessary if you used 3/8 aluminum plate instead of 1/4 inch for the end plate shown in the drawing. These are the materials that will be needed. A 5/8 inch 12L14 round bar at least 6 inches long to machine the drive shaft. A piece of flat bar aluminum 1/4 inch or 3/8 inch by 1.5 inches at least 5 inches long. A sealed bearing with dimensions of 12mm inside, 28mm outside diameter, and 8mm width, and two M6 by 20mm screws. To create the drive shaft, I faced off and created a center point on both ends of a 7-inch long 5/8 rod. Then I mounted a dead center in my 4-jaw chuck and dialed in the point to 0, run out, and placed the rod between the dead center and a live center in my tailstock. Using a lathe dog, I turned down most of the rod, just enough to remove the mill scale and assure a perfectly concentric surface. Then I turned down 18mm of the rod at the tailstock end to 12mm, making sure to leave a right angle step at the retaining shoulder. I removed the rod from the lathe and chucked it in a square collet block to mill the flats on either side of the turned down portion of the shaft. The drawing shows this tang to be 4mm, but mine turned out to be just under 5 for a close fit, so I started out by milling 3.5mm off each side and made additional small cuts, testing until I got a good fit in the end of the X-axis table shaft. This area looks like many I have seen on other small mills, so they're probably all made in the same factory in China. Then it was back to the lathe between the centers to turn down the remaining portion of the drive shaft. The drawing shows this to be 25mm, but I allowed for additional length to cut the shaft away from the rod. Leaving the 1mm retaining shoulder, I turned down a little more than 25mm to a diameter of 12mm and made sure to leave a right angle step at the shoulder. Finally, I removed the rod from the lathe and fit the rod in the hex collet block to mill the drive end of the shaft for a 10mm socket. Once this was accomplished, I cut the shaft away from the rest of the rod and deburred and dressed it. Now for the faceplate. I started by cutting 5 inches off of the 1/4 by 1.5 inch aluminum flat bar. I milled the ends square and reduced the length to 120mm. I marked the exact center and drilled a 1/2 inch hole for the shaft. Using the dead center in my lathe tailstock to center it by the 1/2 inch hole, I mounted it in my 4-jaw chuck to bore out the recess for the bearing. This had to be 28mm in diameter and 5 millimeters deep. With the bearing firmly seated in this recess, it protrudes 3 millimeters, so I had to bore clearance for this in the original table end plate using the same 4-jaw chuck process. Since the shaft would provide alignment, this was bored oversized to 29 millimeter diameter and 3 millimeter deep. I clamped the two end plates together using a 15 32nd inch drill bit to align them and used a center punch to mark the two pilot holes for the M6 screws. I drilled the two holes very close to the screw size to provide some alignment. The job was done except for cutting the corners off the new faceplate to match the original end plate and deburring and dressing everything.